Okay, we're going to talk about the monthly space news covering since the last meeting, which was about a month ago. And we'll start right off with the exciting crashes. But just to give you an idea of what's in the highlights of this news this month. Planetary defense, we'll start off with that, of course. That involves DART, in particular, the asteroid crash. Also, there's other spacecraft out there doing things. Juno just passed by Europa, moon of Jupiter. India had a Mars orbiter that's been in orbit for 8 years. It's finally reached the end of its life. LunaGrid is a power grid that is being planned for the moon. Firefly is a new rocket company, finally got their first rocket into orbit, and that was only on the second try. That was actually quite good. Artemis One, the moon, actually around the moon, that's been delayed again. Blue Origin had a flight failure, and some few other odds and ends that are kind of follow-ups from previous meetings. So let's get right into DART. It stands for Double Asteroid Redirection Test. I won't spend too much time on the background because we talked about this last month and also actually back when it was first launched. It was a test of planetary defense. The idea is you crash into an asteroid. It's a binary asteroid, so you crash into the smaller moon called Dimorphos. And it's hitting at about 15,000 miles per hour. We'll be able to tell how effective this was in altering the orbit by watching the period. The small asteroid comes around, it blocks light from big ones, so you can see a variation in the light. And that's the same way you detect planets. It is expected that it will change it from 1 to 10 minutes out of a 12-hour period that it currently has. This thing was launched back in 2021 in November.
It uses a camera to guide itself in and to do the crash. Essentially, that's missile technology. Usually most things you think of as being guided by GPS, but that's always been an alternative. As you match a picture, you essentially just aim for the center of a picture, and so they have the controls to do that. And I think they actually use some old missile control software for that. This had to be completely autonomous once you got within about 4 hours of impact. The transmission time, you couldn't possibly control it remotely, so everything was autonomous after about 4 hours before the impact. Now, how are we going to tell what happened? Well, there's a variety of ways. The Italians have built a small CubeSat, a very small satellite, about 10 units. For a CubeSat unit is 4 inches cubed. It's a light satellite that was dropped off about 15 days before the impact. So it'll watch it, and it did. It took pictures before and after, and it's hanging around in that area. There will be a follow-up mission out of the European Space Agency, specifically by Italy, project called Hera, and they're going to go visit it in a few more years. At least they'll launch the craft to go visit it in a few more years. A few statistics I didn't mention last time. So we're hitting this moonlet called Dimorphos, and it's about 535 feet in diameter. They estimate it weighs about 11 billion pounds. Okay, so even that's a small asteroid. It's a lot smaller than what killed the dinosaurs, but still a lot of pounds. By comparison, we're hitting it with something that weighs 1,100 pounds. So it's a factor of 10 million difference. So you better hit it pretty fast if you expect to see much of a change. And that's why it is hitting it around 15,000 miles an hour, which isn't that different than the escape velocity from Earth in the first place. So I will comment, this was an artist's illustration. This is the one they've used for the last couple of years when talking about this project. And if you look kind of closely at them, Dimorphos in particular, it doesn't really look like this picture. Nobody really knew what it looked like until we just got there just now. If you've looked at other previous asteroids, this is basically Ryugu, which was an asteroid that the Japanese landed on and took a sample and came back from. So they had close-up pictures, and they pretty much stole that, figuring, okay, let's just pick an asteroid, and that was it. So here's what it really looks like, this egg-shaped thing on the left-hand side. And then as it was closing in, this picture was taken 2 seconds before impact on the right-hand side. This is what it looks like. It basically looks like a bunch of boulders. And in fact, they call it officially, the technical jargon for such a thing is a rubble pile. So, you can impress your friends with technical jargon. This is actually called a rubble pile. So why do we need DART in the first place? Well, first of all, asteroid hits have happened before. It will happen again. This proves that we can hit even a small and distant target, which, might have been questioned, say, 20 years ago. So now we've definitely proven we can do at least that much. But the real question will be, how effective will it be? And a lot of that depends on what the material of the asteroid is. For instance, if it's a really hard rock, and there are some of those, like the Psyche asteroid, which is thought to be mainly a former molten core of a planet, pretty metallic, that's really solid. If you hit that, there's an artist's conception of what would happen in the upper left corner of this slide. The idea was you'd hit it, and it would probably just shoot up a little bit of material, just kind of in one fairly narrow little beam. That actually would make the DART impact more powerful. Essentially, you get an extra kick because not only are you hitting the planet and transferring the momentum into the planet, but the fact that some of it shot back the other way by balance, in effect, it applies more force. So that would be good if it's a really solid asteroid. Unfortunately, it's looking like the typical asteroid is probably a rubble pile, meaning they're really a bunch of boulders that are held together by gravity, somewhat loosely. And this one might be it. The worst case, a craft might just go right through it. For instance, it would be hard to land on it. That's what they found out in the last couple of asteroid sampling missions, both Bennu and Ryugu. They tried to land, and they had a hard time even landing or drilling into it because it's just such soft material. What are alternatives for changing the course of an asteroid? Well, one that you always see in science fiction movies, besides hitting it and blowing it up, the other thing is put a rocket engine on it and turn it on and just have it go away. Well, if you just got a pile of rubble, that's probably not going to work. You'd probably just kind of push your way through the rocks, and that wouldn't work at all. If you blow them up, they could actually just recoalesce, and that supposedly happens upon impact. Yeah, they'll go apart, but eventually they'll just work their way back. And it might only take hours, it might only take weeks. But in any case, you wouldn't have accomplished a whole lot. We needed to get some real-world experience with this, get a feeling of what's going to happen. Now, they have actual pictures taken from the Lichia cube, the Italian CubeSat, and that's on the right-hand side here. The big one in the front, of course, that's the main asteroid, but the one they blew up is the one up here on top. And it looks like there's stuff just shooting out almost every direction. They call it a crescent because it's one little area that maybe it doesn't. But that would probably indicate this thing was a pile of rubble, pretty loose. So it's kind of hard to say what'll happen. And it's especially hard to say what'll happen because it's a binary asteroid. You can move stuff around, but some of that's going to hit the other asteroid and change it. In any case, even just through normal gravity, you try to change the path of one, you're going to pull the other one along. You put a big rocket on the moon, you would drag the Earth to some extent with you too. So there's going to be a lot of interactions. It'll be very hard to really model this very effectively. People have tried, of course, but you just don't know what will happen until you try it. So there's a couple of obvious issues with this kind of planetary defense. The first one is, well, obviously you've got to detect the asteroids way ahead of time because you're not going to be able to change their orbit or their path very much. But the theory is if you do it early enough, you don't have to change it very much. So that means you need to detect them early. Then the second thing is characterizing them. If you don't know if it's a pile of rubble or a really solid thing, you're not quite sure what's going to happen. So all those things will still make planetary defense hard.
Doug Hall had a question about how much advance warning we really need for asteroids.
Years, decades, ideally. It depends. If it's something that came in even from outside our solar system, yeah, who knows? I mean, you might only have a little bit of time. But, most of them are assumed to be in orbit, but just not noticed yet. Well, yeah, how do you estimate how many are unknown? I've seen wildly varying estimates. Yeah, they think there's probably a lot of them out there that they just don't know about. There's a project called the NEO Surveyor, a near-Earth object. The reason you can't see a lot of asteroids is they essentially go inside the orbit of the Earth. The problem is you look that direction, you're looking toward the sun, and so they pretty much get blocked out. So the idea was, well, why don't we put something in between the Earth and the sun at the L1 point? That's a great idea because as the Earth rotates around the sun, it stays in constant distance so you can exchange data very easily. And it can look back. And so this craft would be designed very much like the Webb Space Telescope. Big solar shades on the side facing the sun, and then it would be facing outward, typically looking before and after the Earth orbit, and have a good view of it. So that was the idea. They set up a program to do this. First of all, there was a mandate from Congress back in 2005 saying that we should find 90% of these things. Obviously, again, how do you count? Who knows? But the idea was look a lot harder. But the thing is, they said that, but nobody ever really funded it, and NASA didn't really push it either. Like, nobody was really that interested in doing it. Then in 2019, we had one of these near misses where there was an asteroid that came actually in between the moon and Earth, and it was a surprise to everybody. Nobody even knew it until almost right before it happened. So that kind of woke people up a little bit that, yeah, maybe we better think about this a little more carefully. So what they want to do is they want to catalog all the near-Earth objects, meaning by their definition, larger than 460 feet. That it's some translation from meters. It's a nice round number. And within about 30 million miles of Earth's orbit. So things that might possibly threaten Earth. And we'll see what happens. Congress really didn't push it. NASA didn't push it. But now we really think we need to. They're getting some funding, so they're doing design work, but they haven't really fully funded this program. It is an official position of the National Space Society. They are lobbying, along with other organizations like the Planetary Society. Yeah, in this picture here, this is just a visualization of the asteroid belt, which would be the main asteroids. You got the sun in the center there. Most of these asteroids are the ones between Mars and Jupiter. Now, of course, there are other things that could come in. They could come in from out in the Kuiper belt or whatever it is. Lots of other places, but at least a lot of them haven't really been cataloged yet. They will come, and yeah, maybe every 65 million years you get one that dinosaur killing size. Nobody knows.
Doug asked for details about the 2019 near-miss asteroid. It passed within the Moon's orbit, within about 44,000 miles. That's only 1/5 of the distance from the Earth to the Moon. The estimated diameter of that asteroid was 200 to 400 feet. If it were 330 feet in diameter, 100 meters, it would have released the power of a 50 megaton bomb. The scary thing was that it only was discovered the day before the near miss. Doug pointed out that only looking for near-Earth objects bigger than 460 feet isn't really good enough. The 60-foot diameter asteroid that hit Russia in 2013 caused an explosion 30 to 40 times stronger than the Hiroshima atomic bomb and injured 1,200 people.
Well, what they said was that they had to catalog the ones that are bigger, but what they're saying in the actual program, they think they can get down to about 100 feet. So at least it's getting closer to that. Now, one thing about this, it uses an infrared telescope. You can't do that too well on Earth because the atmosphere gets in the way too well. You want infrared because most asteroids are black, or at least very, very dark colored, and it's hard to see them. So, but in infrared, they're still emitting plenty of heat, and so that's why it's important that it be an infrared telescope. And I think it uses a couple of infrared bands to actually accomplish this. So, interesting project. Is also just interesting that it never really got serious attention, despite even a congressional mandate back in 2005. Okay, moving on to Juno. This is another spacecraft that's been up there for a while. It just recently flew by Europa, which is a moon of Jupiter. It is considered by a lot of people the most likely place you might find life outside of Earth, within our solar system. The reason being that although it has an ice crust, maybe 10 to 15 miles deep in most places, they're pretty sure it has a saltwater ocean under that. So you figure, okay, well that's a likely spot for life since that kind of thing works on Earth. So that's a good try. Nobody knows, but it's attractive that way. And for reference, it's about 90% the size of Earth's moon. Now, this probe passed within 220 miles. Now, the thing is, the probe is also going 50,000 miles an hour, so it doesn't have a whole lot of time to take pictures. They figured they had about 5 minutes to get really close pictures, so that's what they did. They got at least 5 pictures. The nice thing was that this has been imaged before by the Galileo probe 20 years ago, but different areas, so we actually got different images, and it's much higher resolution as well. The spacecraft, what it looked like, an artist representation is up there in the upper right corner there, just seeing it with Jupiter as a background. The mission itself started off mainly being oriented toward Jupiter. Like most of these craft, it seems to last forever, so they decided to then repurpose it and visit at least 4 of the major moons as well. So this is really an extended mission. The original mission maybe flew by one moon once, but that was about it. The lower right corner shows what the surface looks like. Lots and lots of ridges. People think that blotch in the lower part of the diagram there might be some kind of a spot where the crust is very thin, for instance. This is an infrared camera. The cameras they're using, in fact, are the ones they really use for navigation. They're ones they're looking for stars, but they're in the infrared, and they get pretty good pictures from them. On this picture, you're looking at about 100-mile width, the lower picture there. And I saw something on what 1 pixel was some small number of kilometers, maybe single digits, something like that. Okay, India's Mars orbiter. I mentioned this in the very beginning. It's been orbiting Mars for 8 years. Its propellant got used up. It's been up there doing a good job. A main issue for a solar-powered craft like that is what happens when it gets behind the planet. There's an eclipse, in effect. They have been maneuvering around to avoid this problem, but they hit a couple almost in a row, and one of them was 7.5 hours long. The design only gave them about 1.5 hours in the darkness. They've been able to continually reposition this thing to avoid this problem until now. But now they just couldn't do it. So the battery died, and it's pretty much declared as it's over. You can definitely consider it a success, though. They've mapped Mars quite extensively with their cameras. They also did quite a bit of studying of the atmosphere. They had several other instruments on board. They had an elliptical orbit that was pretty high, and as a result, they could look through the atmosphere. The U.S. orbiter is quite a bit lower orbit, and it's almost too close to the planet. You're mostly just seeing the planet itself, whereas they were far enough away that they could actually do a good study of the atmosphere. Another amazing thing about this was it only cost $25 million. They call it frugal engineering. So I think there's definitely some congratulations in order for this. Next project's kind of an interesting one. This is future. This is not here yet. LunaGrid, and it's a project by Astrobotic, a Pittsburgh company. What their plan is to actually have commercial service for lunar power. And it's going to be a long-term solution is the idea. The problem you have on the moon is most parts of the moon, you got 14 days of daylight and 14 days of night. The day-night cycle is 28 days, half of which is dark. It's hard to survive that. So you got to work really hard, have really big batteries or nuclear power or something. So they got a contract. They've actually gotten several contracts to address this problem. They already had a $6 million contract to develop prototypes for these vertical panels you see here. And the idea is if you're near the lunar poles, then the sun is never that far away from the horizon. So you just put your solar cells up on the poles. You may have to move them a little bit depending on your position. But that's why you look at these panels here. The idea is you just stick them up high enough and they can always see some sunlight. If they have to move them a little bit, they put them on wheels so they can move them around as they need to. Now, the total deployed cost of this would probably be a couple $100 million, but the initial project is a lot less than that. They're saying it could be operational in 2028. Probably parts of that could be sooner because they already had these solar panel things underway. What they're saying is essentially there's not really an exotic new technology that's needed. It's really just doing the kind of stuff we've done before, but just assembling a system like this that is a little bit different. So the way it works is you have the vertical solar arrays that go and find the sun, because the sun is always low, but it's there. The other interesting one is they have rovers that are tethered. You see this in the bottom of the picture here. They have a rover, which they had already developed under a previous contract. It's tied by a wire, and then they use wireless charging, pretty much like you'd use with your phone, just a bigger version of that. So they just say it needs to go up near the customer, assuming the customer has the same facility. They can use that. They've said they want to target a 10 kilowatt capacity. This would be scalable. You just build more and more of these things. But their initial one would just have a few panels and a few rovers to go get the power delivered. And also, they already had a delivery system to get it there. They have a lander called the Griffin lander, which is funded separately. That one is used by more companies than just them. And that's due to land in a couple of years anyway. That's in the lower right corner down here. We've showed this one before. There's basically like a little bridge to come off the top. You roll the rovers down off of that and go from there. So this is kind of interesting. What they did was they've been working piece by piece to fill in all these little pieces on how you can actually get power to the moon. And it looks like they're now saying they can do it. And so they've got some funding to do it. They'd already gotten funding for the pieces along the way. Firefly. People have probably heard of that, but not heard much about them. This was their second try to orbit. They finally did. And they actually launched 3 small payloads, about the size of a loaf of bread each. And one of those then, in fact, split into another 4 satellites, really small ones. But they made it to low Earth orbit on October 1st. It is a small expendable rocket. It's not quite as small as that Astro rocket that we've talked about before, but it's pretty small. 95 feet tall, 6 feet wide, weighs about 54 tons. So its payload is 2,580 pounds. That's the maximum visualized to a low Earth orbit. And they would sell that for about $15 million, which is more expensive than you would pay SpaceX, but you can get a dedicated launch. So that's how the competition is working in this business. That if you want a custom and fast access, you go to one of these kind of companies. Their claim to fame is that the whole thing is built on carbon fiber. That is the body and the fuel tanks. They say they are the largest all-composite rocket that exists. So that's their claim to fame. Their booster engines use kerosene, a fuel called RP1, which is a kerosene, basically, liquid oxygen. They named them Reavers just to emphasize that it's not just an insect they're naming themselves after. They're making the reference to the Firefly science fiction series here. So their emphasis is the quick launch, which gets a lot of attention from the U.S. Space Force. They get contracts from them as well as NASA. I think they're actually pretty well funded as a result. So their competition already would be including Rocket Lab, include Virgin Orbit. They're the people that launch from a plane, and then send on up to orbit. The biggest competition is still ride sharing, typically from SpaceX, where they put together these missions that maybe put up 50 or 100 satellites at one time, but they don't all go exactly where you might want to go. So that's the trade-off. But they just managed to beat out their other competition that's coming along, Relativity Space and ABL Space. ABL was probably about ready to launch. They've just been held up by getting permissions and so on. And these people are projecting about 6 launches. So I think they're probably going to be a pretty serious player in the small rocket business. It's still not that clear that the small rocket business is that big a business, but they probably will have a place in it. So a little bit more about them, since it looks like they're probably here to stay. One of the reasons they're probably here to stay is that they've teamed up with Northrop Grumman to build the Antares 330 rocket, the first stage. We've talked about this before, that the Antares rockets, these are the ones that typically take the Cygnus cargo craft up to the International Space Station delivering cargo. That's been their main role for quite a while. Antares rockets have been around a long time. But the most recent generations of those were built in the Ukraine, and they use Russian engine, the RD-181. Well, 2 things happen. Of course, one is we're not going to buy rocket engines from Russia anymore. But the other thing is actually the factory that was producing those is probably flattened at this point. I'm pretty sure it is. So that's just gone. It's out of the picture. They had to do something else. And by the way, Northrop Grumman even had maybe 150 engineers in a design center in Dnipro in the Ukraine. So Ukraine actually had more of a space industry than most people realized, I think. but not now. This one uses 7 improved version of those Reaver engines, again, kerosene, liquid oxygen. These people were planning on building their own rocket anyway, called the Beta. The first one's called Alpha, and it's the next one, obviously, then it's going to be called Beta, bigger. And what they're selling to Northrop Grumman is essentially their Beta rocket, just slightly modified. But they have other projects going on as well. The Blue Ghost lunar lander, we've talked about the CLPS program, which is Commercial Lunar Payload Services. It's all part of the NASA Moon to Mars program. They already had been funding lunar landers, and they were funding the one from Astrobotic, for instance, we talked about, but they also had funded Firefly as well. So they have multiple sources of funding. They're located in Texas, by the way, a suburb of Austin. Their headquarters and their factory are right around there. So what you see on the right-hand side here, this is a visualization of the Antares rocket as it'll look, and there's also their lander. That's what's on the lower right corner here. Okay, moving on, Artemis One got scrubbed again. This is the 42-day mission to go around the moon without a crew. It had passed their tanking test where they finally filled the thing up with fuel completely. They hadn't done that. They had small hydrogen leaks, but it wasn't bad. And the big question had been about the battery for the flight termination system. In the event of a disaster, they could blow it up remotely, and they need batteries to do that. They've been getting waivers, and the last one was going to expire October 2nd. There were also a variety of smaller satellites being launched, and the status of their batteries wasn't known. But anyway, Hurricane Ian came along, and they said, okay, we have to put this thing back in the building, protect it. Their launch is delayed to at least November at this point. A side note there, on the left-hand side, you can see the rocket being moved. The thing at the bottom is called a crawler, and there's a picture on the right-hand side of what it actually looks like. That thing is 50 years old. That was used to move the Saturn rockets. It was used to move the space shuttle. They did rebuild it for SLS. And in fact, they have to rebuild it for the next version of SLS, which will come after the first 3, because that one's heavier. It's about a 4-mile trip. Top speed is somewhere between 1 and 2 miles per hour, 1 mile per hour loaded, 2 miles per hour unloaded. And this thing has over 2,000 miles on it already. So that kind of gives you an idea just how much this has been used in the past.
Doug commented that the early flights also used hydrogen, so they had the same kinds of leak problems currently faced by SLS. So as a result, they spent a lot of time going back and forth between the launch pad and the vehicle assembly building.
Exactly. And the same thing for the space shuttle. They went through a lot of periods like that, too. In fact, we mentioned last month, they had like a 6-month stop while they were troubleshooting. And that's why there were over 2,000 miles on that crawler. Okay, so just miscellaneous items here. Blue Origin, they have their new Shepard rocket. That's the suborbital one that you see Jeff Bezos going up in. They had their first actual failure since they've been offering commercial service. But this one didn't have people on it. It was just 36 payloads, just cargo, science experiments, that sort of thing. So there's an abort mortar, and that saved them. So there's 2 pictures on the right here. The one on the bottom shows you basically when things started to go wrong with the launch. And then right away, there's an abort engine that fires, and you're seeing here the capsule. I think at this point, the rocket itself, the booster was probably still in there. You just can't see it for all the fire. But anyways, it saved the capsule and worked as planned. So the combination of the motor, removing it, and then the parachutes. You might say this was a good test of the emergency abort system. In some ways, it gives you confidence that even if things go wrong, you can get back to Earth all right. It worked the way it was supposed to. Another one I'm not going to talk about because I haven't had time to look at them yet, but remember NSS had done a presentation to NASA on things that we thought were probably not quite right with their objectives. And this was a meeting of invited people, and I was actually on the group that did that. We gave them a lot of feedback, as did a lot of other people. So they've now revised their objectives in response to all that input, including ours. I haven't had a chance to look at them. I wanted to at least highlight that at least they have done something, and apparently they made some improvements, but I really haven't had a chance to look into them. One final thing, we talked last month about Masten Space going bankrupt. They were one of these lunar lander companies. It all got sold off to Astrobotic, and they even rehired all the employees. So all that work probably won't be lost. They had a separate lunar lander. I wouldn't think they would keep that going because Astrobotic already had their own. But anyway, that's just for completeness. Okay, so how many launches do people think we've had? We do this every month, and remember that includes failed launches as long as they were trying to get to orbit, Earth orbit or beyond. The one picture I've got here, this is a Falcon 9 rocket. It launched a bunch of satellites, including the Blue Walker 3 satellite we talked about last month, which is the one which is testing out doing normal phone service from space. Well, normal phone service if you're only doing SMS messaging. So I'll give you that one, but how many launches do you think there have been in the last month?
2,000.
You're coming down. That's better than 1 million, I got to say. You're still high now. Well, you're getting close. Okay, it's in between. I'll give you a clue. It's in between those 2 guesses. We've now, it's called a bound and branch search or something, right? Okay, the answer is it won't fit on one page. I won't talk about most of these because most of them, like every other month, pretty much the same. You get a bunch of Starlink satellites going up for internet service out of SpaceX, a bunch of military stuff going up for China and sometimes America. Now, one interesting one was a mission to the International Space Station, the ISS. That crew went up in a Russian launch, but it did include one American. We're not cooperating with Russia on anything anymore, but actually that arrangement still stands. It's a swap arrangement. And I mention that because we also just sent up one back on October 5th, just a couple of days ago, and that included the Russians. So we're not allowed to pay money to Russia, but Russia and America still swap. Again, the idea being to run a space station, you really need both Russians and Americans there. Nobody wants to be in a position where there's no Russians or no Americans on it at any one time, and then the swapping of seats helps. So amazingly, despite everything else, that's the one area that we're still cooperating with Russia. Nothing else really that unusual.
Doug was impressed that Firefly reached orbit on its second try and was wondering about the failure of the first attempt.
They tried it last year the first time, and they had to abort. They had a loose connector or something, so one of the engines didn't really get going. The thing went ahead and took off, but they used the flight. No, that was an Astro rocket. This one actually apparently was a little more robust than it. It had enough thrust to get going anyway, but they blew it up after it was up somewhere in the sky. The flight termination system was used, which means they blow it up just to make sure it doesn't land on a populated area or something. So, and as usual, of course, most of the launches are either American or Chinese. There's there was the Russian one for going to the space station. There's a lot of lasts coming in here. One of these Atlas V launches is the last of the Atlas of that particular configuration. They have different configurations. I think they still have 15 or so left.
Atlas 5 is ULA, right?
Yeah, as is Delta. So, yeah, I should have mentioned that. Now, this is the Delta IV Heavy one. This is the last launch that's going to happen from the West Coast. This is out of Vandenberg. They still have a couple of those old rockets left, but they're going out of Cape Kennedy on the East Coast. So, space station we talked about. So, Starlink, there's more and more satellites up there supporting internet service. There's about 3,400 of them in orbit now. Now, not all those are active. Some of those are still going up to their final orbit. Some of those might be dead. Most of them have been deorbited when that happens. An interesting one, there's an Electron launch in there. They haven't been launching for a while. There's a constellation of satellites, quite a few, that called Argus. They've been around for many, many years, but they do things like, if you want to monitor whales, when they come up to the surface, then they can handle very, very low power signals. It's international. It's NASA, and that's combined with the French in particular. The satellite is built by General Atomics, which is an American company. And it's funny, they claim they're the only people offering this kind of service. It's not really true. We talked before about Swarm. They have little ham sandwich-sized satellites that actually can communicate for the same purpose. And even Iridium does some of that. So they exaggerate. Okay, we probably better get moving along here. Okay, so feature speaker, Lee Basu, a space architect. She is a technical designer at Gensler, which is a global architecturing firm. She's been involved in a lot of space-related stuff, GrowMars, Excalibur was an aerospace company. She worked as a student at the MIT Media Labs, a variety of interesting kind of background here. Master's in Space Architecture out of U of Houston. And I better just turn it over to you.